ass DJ. Sorry ass DJ.
Question number 13 is the function defined by f of x equal to bracket x plus 5 comma if x is less than or equal to 1 x minus 5 comma if x is greater than from 1 to check a continuous function. Given f of x is equal to x plus 5 comma if x is less than or equal to 1 x minus 5 if x is greater than 1. Here x is less than or equal to 1 means that left hand limit and f of a is examined here, and for the x is greater than from 1, that means right hand limit is considered here. That means if x greater than from 1, then f of x is equal to x minus 5, and if x is less than or equal to 1, f of x is equal to x plus 5. Checking continuity at x equal to 1. Left hand limit is limit x approach to 1 from the left side f of x equal to limit x approach to 0 f of 1 and from the left side, so a minus h is equal to limit x approach to 0, then 1 minus h, then is less than from the 1, it is equal to x minus less than 1 is equal to x plus 5, so x is 1 minus h. Let us put 1 minus h plus 5. Then let's put the values of h equal to 0 here. Then 1 plus 5, that is 6. Right hand limit equal to limit x approach to 1 from the right side f of x equal to limit x h tends to 0 f of x here. F of x is greater than from 1, so we take x is greater than from 1, so we take x minus 5. That is 1 minus 1 plus h equal to limit h approach 0, 1 plus h, that means 1 is greater, so we take x minus 5. X minus 5x is 1 plus h, make x minus 5. Then let us put the values of h equal to 0. It becomes 1 minus 5, which is equal to minus 4. Here, left hand limit does not equal to right hand limit. Therefore, x equal to 1 is a point of this continuous. Question number 14. Solution. F of x equal to 3 if 0 is less than or equal to x and x is less than or equal to 1. 4 if 1 is less than x and x is less than 3. 5. If 3 is less than or equal to x and x is less than or equal to 10. Let us check continuity at two different values, that is at x equal to 1 and another one is at x equal to 3. Let us first set the values of at x equal to 1. Left hand limit equal to limit x approach to 1 from the left side f of x equal to limit x approach to 0 f of x here x here f1 minus h, that means which is approaching from the left side of 1 and the value of 1 is less than 1 is equal to 1 is less than is equal to 3. So limit is approach to 0, left of 1 is equal to f of x is equal to here 3, which is 3. Right hand limit f of x approach to 1 from the right side equal to limit f of 1 is greater, that is h equal to 1 is greater, x is greater, 1 is greater from 1, so f of x is equal to 4. So limit h here h approach 0 x 1 is greater than 1 is greater from value is equal to 4, that is 4. Here left hand limit does not equal to right hand limit, hence f is not continuous at x equal to 1. And let us check continuity at x equal to 3. Left hand limit equal to limit f of x tends to 3 from the left side equal to limit h approach to 0 f3 minus h, that means which is left of the 3 and left of the 3 that is greater than less than from the 3 is x less than from 3 is equal to 4. So let us give limit is equal to 0 which is equal to 4. Right hand limit f of x tends to 3 from the right side equal to limit is approach to 0 f of 3 plus h, which is greater than from 3. So greater than from 3 is equal to 5. So limit is approach to 0 greater than from 3 is equal to 5, which is equal to 5. Therefore left hand limit does not equal to right hand limit. F is not continuous at x equal to 3. Question number 15. Solution. F of x equal to twice x, comma, if x is less than 0. 0 if 0 is less than or equal to x and x is less than or equal to 1. For x if x is greater than from 1. To check the continuity at 0 and 1, let us first check at x equal to 0. Left hand limit equal to limit x approach to 0 from the left side f of x equal to limit is approach to 0 f of 0 from the left side, and which is equal to limit is approach to 0 f of minus is equal to for the left hand limit which is less than 0 is here equal to twice x. So limit is approach to 0 to x is minus h. Let us put the values of h equal to 0. That is 2 into 0. That is equal to 0. Right hand limit equal to limit x approach to 0 from the right side f of x equal to limit h approach to 0 f of 0 plus h, that means from the right of 0, and from the right of 0 which is equal to from the right of 0 which is equal to 0, which is equal to 0, and f of a is which is equal to 0. Okay, f of a is also 0 and which is equal to 0. Here left hand limit equal to right hand limit, and f of the all are equal to 0. Hence f is continuous at x equal to 0. To set the continuity at x equal to 1, left hand limit equal to limit x approach to 1 from the left side f of x equal to limit h approach to 0 f of x, it is 1 minus h, it means left side of the 1, which is equal to limit h approach to 0 f of minus h, which is also equal to 0. Right hand limit equal to limit x approach to 0 from the right side f of x equal to limit h approach to 0 f of 1 right side of the 1, that means 1 plus h equal to limit h approach to 0 once, then greater from the 1 is equal to 4x. So 4x is equal to 1 plus h. Let us put the values of h equal to 0. Then 1 is 4. 4 plus 0 is 4. Hence left hand limit is equal to right hand limit. F is not continuous at x equal to 1. Question number 16. Solution. Given function is that f of x equal to minus 2 if x is less than or equal to minus 1, twice x if minus 1 is less than x and x is less than or equal to 1, 2 if x is greater than from 1. This is question 1 and this is question 2 and this is question 3. Let us check continuity at two different points, that is minus 1 and 1. Let's first check at continuity at x equal to minus 1. Left hand limit is given by is equal to limit x approach to minus 1 from left side. F of x equal to limit x tends to 0, f of minus 1 approaching from the left side of minus 1. So minus is written here. Limit is approach to 0 here. For left side of minus 1 is equal to here. Left side of minus 1 is equal to, that means x is greater than from minus 1 is equal to minus 2. So we have a minus 2. F of x is equal to minus 2. And which is equal to minus 2. Right hand limit. Right hand limit equal to limit x approach to minus 1 from the right side of minus 1. F of x equal to limit x approach to 0, f minus 1 approaching from the right side of minus 1. So plus h. Right side of the minus 1 is, that means greater than from the minus 1, which is equal to greater than from the minus 1 is equal to f of x equal to twice x. So it is written as limit x approach to 0 to x is equal to minus 1 plus h. Let us put the values of h equal to 0. Then it becomes 2, 1 is 2, minus 2 plus here is 0. That is equal to minus 2. And f of a is equal to minus 1. And here for the minus 1 is also equal to minus 2. F of x equal to minus 2. Equal to minus 2. Left hand limit equal to right hand limit. And f of minus 1. F is continuous at x equal to minus 1. Again let us check. At continuity at x equal to 1. Left hand limit equal to limit x approach to 1 from the left side of 1. Fx equal to limit h approach to 0, f of 1 minus h, that means left side of the 1, that means less than below of the 1. Then limit h approach to 0, then left side of the 1 is, which is equal to twice x. Twice x is 2. X is 1 minus h equal to, let's put the values of h equal to 0. Then it becomes 2 into 1 minus 0. At least 2, 1 is 2. Right hand limit equal to limit x approach to 1 from the right side of 1. F of x equal to limit h approach to 0, f of 1 plus h, that means right side of the 1, greater below of the 1, approaching 1 from greater below of the 1. So we have to put 1 plus h equal to limit h approach to 0 equal to 2. That means greater below of the 1 is equal to 2, and which is equal to 2. And f of 1 is also twice x, that is 2 into 1, which is equal to 2. Therefore left hand limit equal to right hand limit and f of 1. F is continuous at x equal to 1.